So 6.2, we're looking at multiplying and dividing rational expressions. So we're doing just those operations on those same rational expressions, and then simplifying them, as always. So remember, when we're multiplying your numerator by your denominator, and then it's always assumed, even if it doesn't say, that we will write in the most simple form. So this will give me that 1 over 6. Also remember that you can simplify before you multiply. So for example, if I have this 5/8 multiplied by 4/15, I can simplify before I even multiply. I know that both of these are divisible by 5. That will leave me with a 1 and a 3. Both of these are divisible by 4. That will leave me with a 1 and a 2. And then I can multiply. 1 times 1 is 1. 2 times 3 is 6. So that will help you out a little bit when we are multiplying. So before I do any multiplication here, I'm going to simplify, but either way works. Sometimes it's just a little bit quicker to simplify first. It's a little bit easier because you don't have as big a numbers, but either way is perfectly fine. So I can get rid of 1x from each of these, so that drops me to an exponent of 1. I know that I can get rid of 1y here, so that drops me to an exponent of 1, nothing here. Oh, and I still have 1x and 1x, so I can get rid of that too. So you can simplify diagonally, numerator with denominator, or obviously the same numerator with denominator. So this just leaves me with a 4 and a y, and this leaves me with a 3 and an 8, which is a 24. And then I can simplify that one more time I can divide this by 4, which will give me 1y over 6, or you can write it as just simply y over 6. So you can simplify first, you can simplify after. If I hadn't have simplified, let's see what that looks like here. If I hadn't have simplified, I would have ended up with 4x squared y squared all over 24x squared y. So my x's would be gone. 2 minus 1, the exponents, I'd be left with just 1y up here. And then I have the same thing. I have that 4 over 26y, which will give me y, over 24. Either way, perfectly fine. So let's look at a couple that are a little bit more complex. So it says multiply, leave in simplest form, and identify all your NPVs, or your non-permissible values. So the easiest thing to do here would be to factor first. You can try to multiply this all out, but you're going to have to multiply first by first, first by second, first by last. It's going to take a little while. I would suggest simplifying first if possible. So let's have a look at this in factor. So what's going to multiply to give me 12? And add to give me -1. That's going to be a -4 and a +3. And then on the bottom here, I have difference of squares. So that's a minus 3 and a plus 3. And then this will all be multiplied. So let's factor this again. What's going to multiply to give me 3 and add to give me -4? That's going to be a -1 and and a -3. And then on my bottom here, I can actually just factor out an a. That will leave me with a minus 4. So remember that you can simplify within the expression itself, or you can simplify within the diagonal, because really all this is going to be written, all of this together as a numerator and all of this together as a denominator. So I have a 3 and a 3 here. It has to be the same sign. So if I have a +3 and a -3, those aren't going to cancel out. This will cancel out, and I am left with a -1 all over a. So it looked like a pretty big expression. It's not too bad. It would have taken a very long time to actually multiply all this out, but I do have to look at my non-permissible values. So let's look at our denominator. So I know that a cannot equal 3. It cannot equal -3. If you just have an a by itself, then it also cannot equal 0, and then it cannot equal +4. Any of those values will give me an undefined function. Make sure that you take these from the original and not from here. If I looked at just my final answer, I would just say, well, a can't be 0, but there'd actually be a lot of different values that a can't be. All right, so same general idea here. We want to simplify first, just that we have a lot more variables, but that's okay. So I have this 2 and this pi and this r that can be gone, so I can't, be careful, I can't do this to the d. Remember that this is all one expression. I'd have to have a d minus 2. I can't just get rid of part of an expression. So then on the top here, I would have dh all over d minus 2. So remember, this would have to be a multiplication to get rid of that d. And then if I'm looking for my NPVs, I have a couple different variables here, so I will have to define it for all of them. So I know that r can't equal 0, and pi is a constant, is not a variable, so I don't have to put anything there. And I know that d cannot equal positive 2. Same idea over here. The first thing I want to do is factor where I can. So this is a difference of squares. So minus 3 and y plus 3. Then on the bottom here, I can factor out an r. That's as far as I can go, so minus 1. And then over here, I can factor out an r minus 1. And then on the bottom here, I'm back to my y, and it's just y plus 3. So I can cancel this out, but that's all for now. Oh, but I missed something. I could rewrite this, that r minus 1 is actually a difference of squares. So r squared minus 1 can be rewritten as r minus 1 and r plus 1. So if you get to the end and there's not a lot of stuff that can be canceled out, always check that you have factored everything completely. Then this r can go as well. So that leaves me with nothing over here, and I have y minus 3 all over r plus 1, and then I have to do my NPVs, or the values that cannot be. So r cannot be equal to 0, cannot be equal to 1, and cannot be equal to negative 1. And as far as my y is concerned, y cannot be equal to negative 3. So now we're looking at division, which essentially follows a lot of the same steps as multiplication once we change the sign and multiply by the reciprocal. So remember the rules for multiplication. I would change my sign to a multiplication, and I would flip my second fraction. So remember, it does have to be the second. It doesn't work the other way around. Multiplying by my reciprocal, there's nothing I can cancel out right here. So 35 divided by 3, and that's it. So same thing goes when we have these algebraic fractions. I'm going to have this 3x squared over y squared, and I'm going to multiply, and I'm going to flip this over x. Do not cancel anything out before you do the flip. So you can't cancel anything here, but if there was something you could cancel out, make sure that you change to a multiplication and do the reciprocal first before you cancel anything out. Now I can start canceling out. 1x will cancel out one of these, and I end up with 3x. So remember, you're changing the sign and you're multiplying by the reciprocal. I did something wrong. That should be a 3. Whoops, there we go. So I'm left with actually 1y instead of no y's at all. So that was a y to the 3, so I've changed the 3 to a 2, and I canceled this. Nope, sorry, I changed this. Nah. You get the idea. I changed the y to a 1, so then I have 3, and I have my x and my y. So same general idea as dividing your fractions, except we have some variables. So let's look at these ones. So for these ones, what I want to do is do my factoring first, again, and then you can cancel out and you can add them together. So I'm actually going to, and it really doesn't matter if you flip it first or you do your factoring first. I think I'm going to do my factoring first, and then I'm going to flip it over, just so I don't have to rewrite the whole thing. But I do need to remember to flip it over. So this is difference of squares. So we can factor here, and then on the bottom we can just factor out an x. That's the best we can do. And we end up with x minus 4. All right, so I'm still putting divide because I haven't flipped it yet. So for this one, what multiplies to give me -6 and adds to give me 1 is going to be -2 and +3. And then on the bottom here, what's going to multiply to give me -20 and add, so that's going to be a +5 and a -4. So now I'm going to change my sign and flip, and I guess I still have to rewrite it anyway. So either way is fine. You can flip it and then factor, or factor and then flip it. Evidently it's not going to make as big a difference as I thought. So x plus 5, x minus 4. Just remember not to cancel anything else until you've written it as that multiplication. So from here, I can have a look at what is available and what I can cancel it. So I know that I have this x minus 2 and x minus 2. I've got this x minus 4 and x minus 4, but that looks to be it, and that's okay. So I'm going to have x plus 2 multiplied by x plus 5 is all that's left in my numerator. And then in my denominator, I'm going to have x and x plus 3. You can, if you wish, multiply that all back out, but just as easy, leave it as is. It's just as correct, and it's almost easier to work with in some ways because you can see what you're doing. So don't forget the NPV values. So I'm looking here, I know that x cannot be equal to 0. It can't be equal to 4. It can't be equal to -3. It can't be equal to 2. And because this was on the denominator, at one point we are going to include that it can't be equal to -5. Okay, one more example. So we're going to throw division and multiplication in here. It will be super fun. So I'm going to factor and I'm going to flip kind of as we go. So factoring here, I'm looking for multiplies to 30 and adds to, all right, so that's going to give me, I'm going to have 2m and I'm going to have 2m, and I'm looking at what's going to multiply and give me that -30 and add to give me 7. So it's going to be a -10 and a +3, and then I know that this can be simplified a little bit, so I end up on my numerator with m minus 5 and 2m plus 3. And again, you can factor any way you want. So that was just kind of my work, so I don't need to keep that there. Then on the bottom, I can factor out 2m from this, and that will leave me with 1m, and this will leave me with a -5. Then for these ones, this is going to be difference of squares, but I am going to flip it. I'm going to change to a multiplication, and I'm going to flip it as I factor. So my 6 is going to be up top, and then on my bottom, with my difference of squares, I'm going to have 2m plus 3 and 2m minus 3. So 2m plus 3 and 2m minus 3. And then I'm multiplying again by this 3 minus 2m. Technically, the whole thing is over 1. And I could factor out a -1 from this if I wish, and I do wish, because it's just going to make it a little bit clearer what I'm trying to do. So if I factor out a -1, I'm going to have -1, and that's going to give me a +2m minus 3, which we see elsewhere. So that's why I want to factor out that -1. It's just going to make life a little bit easier. So from here, and again, even though this is a long one and it's technically harder, it's the same steps. You just have to do it multiple times. There's just more room for error. So I can get rid of this here. I have this 2m plus 3. I have this 2m minus 3. I can say that this is a 2, so I can divide it by 2. This divided by 2. And then I am left with, on the top here, I have a -3. Because I have that -1 that's still there. I can't just let that drop. And I have the 3, and then on the bottom, I am just left with, oh, there it is, just that m. So all over m. And I still have to figure out the values of my NPVs. So for this one, I know that, whoops, m cannot be equal to 0 because it's there by itself. I know it can't be equal to positive 5. I know that it can't be equal to negative 3 over 2. And I know that it can't be equal to positive 3 over 2. And I think that is it, because we did flip this. This was a denominator, but there's no MPVs there. So, same thing. You're going through step by step, factor, cancel out, write down what's still there, remember the values that you cannot have.